What's going on, everybody? My name is Nate. Welcome back to Read Derived, and today we're going to be tackling some practice problems for one-dimensional kinematics. So without further ado, let's get right into it.
Run away with me.
Amanda drives 150 miles to her grandfather's house. She covers half the distance at 50 miles per hour and the other half at 60 miles per hour. On her return trip, she drives half the time at 50 miles per hour and the rest at 60 miles per hour. What is Amanda's average speed on the way to her grandfather's house, and what is her average speed on her return trip? Which you would think would be the same because she's going the same speed, but she's doing it for different times. But you're going to see that happen. Okay, so whenever a question is asking for something, I just like to write the formula for it straight out of the get-go to see what we're working with. So first question, part A, is asking for average speed on the way. So I'm going to say average speed, V bar, I'm going to say V bar sub W for way, equals delta X over delta T, which of course is the change in displacement divided by the change in time, where X sub F is our final distance, our X sub I is our beginning distance or displacement, and T sub F and T sub I are our final time and our initial time, respectively. Okay, so let's write down what we know. We know that V bar sub W1 equals 50 miles per hour. And why did I put a little 1 there? Because I have to divide this trip into two different segments because she changes speeds, which technically means there's acceleration. But in terms of average speed, which is what the question is asking for, all we need to do is figure out what these variables are and then plug them in. So what I also know is X sub F minus X sub I, change in displacement. Change in displacement, this value, which equals that value, is equal to 150 miles. And that's the total change in displacement, so across both time segments. But if I were to partition this into two different distances, we have to read the question. She covers half the distance at 50 miles per hour and the other half at 60. Half the distance, half of 150 is just 75. So I'm going to say delta X sub 1 is 75 miles. And I'm going to say delta X sub 2 equals 75 miles. And I know this might be a little confusing, what I'm doing right now, but it's all going to make sense as the problem continues. So let's look at the first half of her trip. Out of this equation, we're trying to find this value. We have these values, but we don't have T sub F. T sub I, we can just say it's 0. We'll start our metaphorical clock at T equals 0 because that's easy. So T sub I goes away. So my tactic here is I'm going to find the time it takes for her to complete the first 75 miles, followed by the second 75 miles, add those times together, and then plug it into this equation at the very end. So what do we have? We have the bar sub W, and I'll just say 1 for this. And of course, I forgot to write the other one, 60 miles per hour, equals delta X 1 over delta T1. So let's rearrange this for delta T. We multiply both sides by delta T sub 1, delta T sub 1. Of course, these cancel, and we get V bar 1 times delta T1, and these are being multiplied by each other, equals delta X sub 1. And now we're going to do the same thing, divide V bar on the way, both sides. Of course, these cancel. Delta T sub 1 equals delta X sub 1 over V bar, right like that. So let's calculate our time. Delta X sub 1 is 75 miles divided by V bar for the first segment, which is 50 miles per hour. 50 miles per hour, which equals 1.5. And we're solving for time here. So we have miles and miles per hour. The 2 miles cancel in our units, and we're left with hours. Okay, cool. Let's calculate our delta T for our second segment of the trip. And we're still in part A. We're still going to the grandfather's house. We're just partitioning this into two segments. So delta t sub 2 is the same exact equation, except now we have delta x sub 2 v bar w sub 2 equals delta x sub 2 is, of course, still 75 miles divided by 60 miles per hour. 60 mph, which equals, calculator, 1.25 hours. So now if we just add these two together, it's going to give us our total time it took for Amanda to get to her grandfather's house on the way. So 1.5 plus 1.25 is 2.75. So delta t for our total on the way trip is equal to 2.75 hours, of course. So now we're going to plug this time into this equation to get our average speed. So even though she went 50 miles per hour and then 60 miles per hour on the way, as long as we have these variables, we can get an answer. So we have v bar sub w using this equation equals delta x. So in this case, now our delta x is the entire trip on the way, which is 150 miles. 150 miles divided by tf minus t sub I, which is the time it took for her to get there, which we already solved for, 2.75 hours, which equals 54.55 miles per hour mph. And you can notice that the units also work out. 150 over 2.75 miles per hour, mph, miles per hour. So we did it right. So I'm just going to write my part A answer up here so we remember. So now let's tackle part B, which is objectively harder than part A, but it makes sense. Okay, so here's part 2. It says, what is her average speed on her return trip? Now, how is her return trip different from her to her grandfather's house trip? Well, it's different because on the way to her grandfather's house, she's going 50 miles per hour and then 60 miles per hour for half the distance. In the second part, she's going for half the time at each respective velocity. So how are we going to work this out? I know it seems kind of confusing at first, but trust me, it's going to be okay. So my main tactic for this problem is to use this equation again and just solve for this v-bar, or velocity. So I'm going to first start by writing what we know. We know that delta x on her way home, x equals 150 miles. And we're going to say that x sub I equals 0. So really, x sub f minus x sub I is 150 miles. What else do we know? Well, we're trying to find velocity, and we don't have our time. So my main tactic for this problem is figure out what this total time is. So the way I'm going to do that is divide this part of the problem down into two segments again. First segment, and then, of course, second segment. Okay, so what do we know about our first segment? Well, we know that our first velocity, half the time home, v sub 1 is just x sub 1 over t sub 1. Okay, so this velocity is just going to end up being the 50 miles per hour that she spent in the first half of her trip. This x sub 1, we don't know. We can't just say it's half of this because Amanda is going 50 miles per hour for half the time, not half the distance. So let's write out our second segment. V sub 2 equals x sub 2 over t sub 2. So what I'm going to do in this problem, since we need this t sub f, I'm going to make two other equations based on the problem and then substitute them into this equation to get our final tf. So what else can we say about this problem? We can say that t1 equals t2. Why can I say that? This part of the problem is divided into two separate halves in terms of time. Half the time she's going 60, the other half of the time she's going 50. So I can just say they're the same and assign it to some arbitrary variable t. So I'm going to rewrite this in terms of this variable t and this equation as well. So we need to say one more thing about this problem before we can continue. I can say delta x is just x1 plus x2. Our total distance traveled on her way home is just the distance she travels in the first segment plus the distance she traveled in the second segment. So what I'm going to do is I'm going to solve this equation for x sub 1. I'm going to solve this equation for x sub 2 and substitute it in here, isolate for t, and then we're going to have our t value that we'll plug into here. So here's what we're going to do. Isolate this for x sub 1. Multiply both sides by t. Of course, t's cancel, and we get x sub 1 equals v bar 1 times t. Not too bad. I'm going to do the same thing for this side. X sub 2 equals v bar 2 times t. Okay, so we have x sub 1, x sub 2 in terms of our other variables. Now I'm going to plug these into here, and let's see what happens. Well, we have delta x equals x sub 1, which is just this value, v bar 1 times t, plus x sub 2, which is just that value, v bar sub 2 times t. And now I'm going to factor out this t to make it look a little bit nicer. You don't even have to do this, but I like doing it. We have this equals to t times v bar 1 plus v bar 2. So, okay, what can we do now? Well, delta x is just our total time over the trip on her way home. Well, that's given in the problem. That's just 150 miles. 150. Which equals t v bar 1 plus v bar 2. Okay, this is our equation. So what I'm going to do is isolate this now for t. So just algebra. So I'm going to divide both sides by v bar 1 plus v bar 2, v bar 1 plus v bar 2. And now I have t equals 150 over v bar 1 plus v bar 2. Now, I'm just going to circle this. This isn't our answer yet, but I'm going to erase this crap so I can keep going. So now all I have to do is relate this t to this delta t, plug it in, and get an answer. So we said at the beginning that t1, first segment time, equals our second segment time, which we just gave to this generalized t variable. How does that relate to delta t? Well, since these two t's are just half the time it takes to get home, we can say delta t is just equal to t1 plus t2. But if t1 and t2 are the same and we call it that, we can just say this equals 2t. Now we can say delta t equals 2t, and solving for t here, we get t equals delta t over 2. All I did was solve for t by dividing both sides by 2 and getting that. All right, now what? Well, t is equal to delta t over 2. Delta t over 2 equals 150 over v bar 1 plus v bar 2. I took this value, plugged it in here. Now, isolating for this delta t, multiply both sides by 2. Of course, these 2's cancel, and we get delta t equals 2 times 150, which is 300, over v bar 1 plus v bar 2. Okay, so let's just plug in our numbers here. This equals 300 over v bar 1, which is 50 miles per hour, 50 plus 60, because v bar 2 is, of course, 60. And this ends up being 300 over 110, which that means we can say delta t equals 300 over 110, which is just 2.72 hours. Okay, so now we're going to take this and plug it into this equation, and we're going to have our answer, and we're going to be done. So just rewriting, v bar home equals delta x over delta t, which equals 150 miles over 2.72 hours. Using your calculator, V bar H is equal to 55 miles per hour. And I rounded up. So this is our part B. One last thing, this is really cool because this is literally the same as saying V bar 1 plus V bar 2 divided by 2, which I kind of just assumed this equation to be true in my previous derivation video, so go check that out if you're interested. Otherwise, let's move on to our next problem. That's the end of the video. I really hope you enjoyed watching me solve these problems. I find watching people solve problems really helps me solve problems and get better at solving problems. So in the next few weeks, I'm going to be posting a lot more problem solving and problem solutions to make Rederive your one-stop shop for everything physics. So thank you and goodbye.
To run away with me. To run away.